Okay, for the polynomial below, you are given one of its zeros. Find the rest of the real zeros. Okay, so we've got a polynomial here. How great, looks like a degree 4 polynomial. Leading coefficient is 2. We're given that c equals 3 is a zero of multiplicity 2. All right, so what we want to do here is be a little bit tricky. Maybe tricky is not the right word. I don't know, savvy? Who knows? But at the end of the day, we're just going to apply this factor theorem here. Remember from earlier, if we have a non-zero polynomial and the real number c is a zero of p, then that means that x minus c is a factor of p. So this is the factor theorem. So we say if we have a zero, then we know that x minus that zero has to be a factor. So we can look at this polynomial we have here and this zero we have here. So the factor theorem has directly told us that x minus 3 must be a factor of this. Well, if it's got multiplicity 2, that means that when we write it out in the factorization, in factored form rather, then we're going to have x minus 3 to the power of 2 present in the factorization. So we got multiplicity 2, that's why we got the 2 there. C equal 3 is a 0. That's directly from the factor theorem. Okay, so we can say x minus 3 squared is a factor of our polynomial p of x. Okay, so, well, what that means is that we can write, if we really, really wanted to, we could write that p of x equals x minus 3 squared times some other polynomial, right? Well, our task is to find that other polynomial. So we can achieve this by long division. So if we divide our original polynomial by something that we know is a factor, we're going to get the other factor. So we can maybe think about this with numbers. So if I've got that 8 is, and I know some known factor of 8, I know that it's 2, well, some other factor. Well, we can find this other factor just by dividing by 2, right? So, and this isn't so crazy when we have it's not so crazy when we have just regular old numbers, right? So if I say that 8 is the product of 2 and some other number, well, we just divide 8 by 2 to find that other number, right? And here it's 4. We can do the same thing with this, where our other polynomial, this is just going to be our original polynomial divided by the known factor. So we can do this in a couple of different ways. I think that I'm not confident that everybody has synthetic division in their back pocket, but we ought to have polynomial long division down. So we can just do this by long division. Once again here, we know that x minus 3 squared is a factor. So let's do a little bit of scratch work first. I guess we probably don't really need to do the scratch work. We can just probably do that in our heads. If we squared this, we're going to get x squared minus 6x plus 9. And this is, maybe I'll write this again because I don't want to leave anybody in the dust here. If I have a binomial and I square it, no matter what, it's always going to be that first thing squared plus 2 times the product of the two things plus the second thing squared. So no matter what, when we square a binomial, it looks like that. And that's where this quadratic polynomial came from. So we just squared x minus 3. So x minus 3 squared is right there. Okay, so now let's do that long division. We want to divide that original polynomial by this. So we can just put that original polynomial down under here. Okay, and now we just kind of go through the motions doing our long division here. So we look at the leading term and we say, what do we have to multiply x squared by to get to 2x to the 4th? Well, I need a 2. and I need to get a square to be a fourth, so I want to multiply by that square. Okay, well, now I take this here, and just like regular old long division with integers, I'm going to multiply this polynomial by this number, and I'm going to put that right under here. So I've got 2x squared times x squared is 2x to the 4. 2x squared times negative 6x, we got negative 12x cubed. 2x squared times 9 would be plus 18x squared. All right, so here's where we're going to make an error if we make an error. When we're doing regular old long division, at this step, we subtract this. So here's where your error is going to be. You're going to want to subtract this term, but not the rest. So in my work, when I'm doing this, I go crazy with those grouping symbols. I don't want to make that mistake. I'm subtracting the whole thing, not just that front term. So I like to put those grouping symbols there to remind myself of that. So I'm doing, here we go. So 11x squared minus 18x squared. That's going to give us negative 7x squared. Negative 11x cubed minus negative 12x cubed. That's going to be plus 12 cubed. So that's plus x cubed. And then 2x to the 4 minus 2x to the 4, that's 0. Okay, now we're going to bring down our 15x. Alrighty, so now we just repeat the process. So now we say, how many times does x squared go into x cubed? Well, it goes in there x times, so we're going to put plus x right up there. And now we can multiply all of these terms in the polynomial by x. So we got x squared times x is x cubed. X times negative 6x is negative 6x squared. X times 9 is 9x. And now we do the same thing. And again, we're being really, really careful. We're not going to make that mistake of just subtracting the front and not the rest. We got to subtract the whole thing. So now we can do it. 15x minus 9x, that's going to be 6x. We got negative 7x squared minus a negative, so it's a plus. So negative 7x squared plus 6x is going to be negative x squared. I forgot to put my plus there. Okay, and now x cubed minus x cubed, that just gives you a 0. Okay, so then we bring down our negative 9, and we are dangerously close to completion here. So we've got the same deal, right? How many times does x squared go into negative x squared? Well, we'd have to multiply that by a negative 1, and then we can just multiply. So we got negative x squared plus 6x, minus. That's a minus. I think that's probably clear, but just to be extra clear there. So now we subtract, and we're going to find that this is super convenient because it all goes to 0, right? Negative 9 minus negative 9, that's 0. 6x minus 6x, that's 0. And this is what we should expect, right? If one number is a factor of another, then we can divide them, and the remainder has to be 0. Okay, so now we're dangerously close to being finished here. What we have done is we have found that other polynomial. So what we can write because of this is that our original polynomial we started with has to be the product of the given 0 of the given multiplicity times this other polynomial that we got after we divided. So we got 2x squared plus x minus 1. Okay, so now we have to find the rest of the zeros. We already knew that 3 was a 0, so the other zeros that we need are going to come from here. And we can just do that by factoring. If we would factor this polynomial, we know that we're going to split it up. If we can, we're going to split it up into two factors, right? And one of these is going to have a 2x in front, and the other one is just going to have a regular old x. So the numbers that go here are going to have to be factors of negative 1. So we want to add, when we decide what to put here, we want everything with an x in it to add to 1x. So we can do this. So if we put, we want it to be positive. So we want positive 1. We want the bigger number to be positive. So we got 2 times 1 is 2. And if we put a negative 1 there, we've got negative 1 times 1 is negative 1. So if we multiplied that out, 2x times x would be 2x squared. 2x times 1 would be 2x. Negative 1 times x would be negative x. And then negative 1 times 1 would be negative 1. So we've got all of our terms, and that is good. So if we're finding the other zeros are going to come from this. So either 2x minus 1 equals 0, or x plus 1 equals 0. So this one, we can solve these really quickly, right? Add 1 and divide by 2, x is 1/2. Or we can just subtract there, x equals negative 1. So there are your other two zeros.